Okay, so this is related rates. Part 1. And this is the first application of derivatives we're going to deal with. All right, so related rates. In calculus, when you see rates, you should automatically think derivatives. Those derivatives are an instantaneous rate of change. So essentially all we're doing here is we are relating two derivatives. And you will be using implicit differentiation in this. All right, so let's take a look at an example. This is probably the best way to start and show you how to do this. So the example, the volume of a sphere is expanding at a rate of 3 cubic centimeters per second when the radius is 2 centimeters. Find the rate at which the radius is changing. And if they don't tell you otherwise, assume that rates, we're dealing with time rates. Okay, so let's take a look at this rate. Volume, 3 centimeters per second. So I could come back in and I know then that dV dt, which is my instantaneous rate of change of volume with respect to time, is going to be 3 cubic centimeters per second. Okay, when the radius is 2, so r is 2, and we want to find, so that's our unknown, the rate at which the radius is changing. So the r dt is our unknown. That's what we're finding. All right, so in order to work this, your first step is going to be write an equation. All right, so which equation do we write? That's a good question. Volume of a sphere. There we go. So volume of a sphere equals 4/3 pi r cubed. All right. And this is probably the hardest part. Then the second thing, take the derivative with respect to time. Or you're looking for ddt. All right, well, we can do that. Here it is, so I come along, dv dt is going to equal to, these are constants, we're going to keep them out, and then I want to do d dt of r cubed. So here's where the implicit comes in, or you can think of this as chain rule. So I've got dv dt equals 4/3 pi. Now I take the derivative of r cubed, which is 3r squared, times the derivative of the inside part, which is dr dt. So there's my equation with derivatives. And then the third part is grading, which is plugging in and solving for your unknown. So there was our only calculus step right there. So let's come back in then, and we're ready to come in and grade this guy. So dv dt, I've got a value for that. So I know 3 equals 4/3 pi, 3 times, r is 2, should have been centimeters, times 2 squared, times dr dt, which is what we're trying to solve for. So I'm going to go ahead and simplify some things out as much as possible. So I know 3 is going to equal 2. Now, 4/3 times 3, these are going to cancel out. It's going to have 4 pi, and then 2 squared is another 4, times dr dt. Or 3 is going to equal to 16 pi dr dt. And now I solve for dr dt, which means I divide by 16 pi. And we solved it. We're done. Okay, let's take a look at a second example here. Actually, yeah, let's go ahead and take a look at the second example. This is going to be more similar to one like you're going to start working with. So, in this example, I've got a point. It's moving along a path given by y equals x squared plus 1. Find dy dt when dx dt is 2 centimeters per second and x equals 1 centimeter. So we're finding an instantaneous rate of change here. And this looks a lot like physics, except that we're actually working with instantaneous stuff. Okay, so we've got our equation right here. So we start taking derivatives with respect to time. So we end up with dy, and that's going to equal to d dt of x squared plus 1. Okay, that's 0. So dy dt is going to equal to 2x, the derivative of this, times the derivative of the inside part, which is dx dt. There's our equation. Okay, so now all we have to do is grade it. plug the stuff in. dy dt is what we're trying to solve for. Well, that's nice. So there's our unknown. It's already solved for. All we have to do is start plugging numbers in. So 2 times x was 1, and dx dt is 2. So dy dt will be equal to 4 centimeters per second. And there's the rate at which dy dt is increasing when x is 1 and is changing at the rate of 2 centimeters per second. Okay, so one more example. Before I do that, there's some formulas you need to remember. All right, distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Although an easier form for calculus is to deal with square distance, which will be x2 minus x1 squared plus y2 minus y1 squared. And this is probably the preferred form when you're dealing with calculus. The other one you're going to have to remember is x squared plus y squared equals c squared. This is the Pythagorean theorem. Yeah, it's back. All right, so let's go in and take a look at another example. So I want to find rate of change of the distance. That word right there ought to have kicked off a warning bell in your brain between the origin and a point moving on y equals x squared plus 1. Okay. So find dy dt when dx dt equals 2 centimeters per second and x equals 1 centimeter. Okay, there's some key words in here. Distance formula. All right. Now it's moving along here between the origin, which is 0, 0. So what this tells me is x1 is 0, y1 equals 0. Well, that makes this really nice because then these are both 0. So we're just dealing with x squared plus y squared. Okay. First thing I always like to do on problems like this is to actually draw myself a little picture so I have some clue what I'm doing. So here's my coordinate system. Here is my origin, and here is the path, and this is the distance we are solving for. All right, so what we're going to do then is I'm going to solve for square distance. So I know d squared I'm going to go capital D because we're taking derivatives, will be equal to x squared plus y squared. The minuses and the subs went away because my first point was 0. So now we can find this for any x and y point. All right, so what I do now is I come back in and I substitute in for my y squared. So I'm going to have d squared will be equal to x squared plus, and I want to substitute for y squared because they gave me x. And then I want to have x plus x squared plus 1 squared. Okay, let's go ahead and expand this out. X squared plus x to the 4th plus 2x squared plus 1. Combine my like terms. So d squared is going to equal to x to the 4th plus 3x squared plus 1. Okay, so now what we want to do is come in and take the derivative. So I do d dt of d squared will be equal to d dt of this mess. Okay, so first thing I do is take the derivative of this thing. That gives me 2d times dd dt. Okay, think of this as chain rule or implicit. And now I come back in and I'm going to do this. That gives me 4x cubed dx dt plus 6x dx dt. And that one goes to 0. And we are looking for, what was it we were looking for? The rate of change of distance. So this is what we're solving for. Okay, so what I'm going to do, but before I do that, let's do 2d dd dt. I'm going to factor out my dx dt. So I've got a dx dt times 4x cubed plus 6x. Yeah, I know you can factor an x out or a 2x out, but in this case, this is what we're interested in. And now, to solve for dd dt, I'm going to divide by 2d. It's going to be dx dt times 4x cubed plus 6x over 2, and d is my distance, which is going to be the square root of x squared, or excuse me, it's what we had up above it. We already did this. We found d squared up above, if you remember. We found d squared was x to the 4th plus 3x squared plus 1. So d is just going to be the square root of all of that. So it'll be square root of x to the 4th plus 3x squared plus 1. And I know you don't like to leave radicals in the denominator, but in this case, let's go ahead and leave it like this rather than worried about rationalizing it. And that's your answer right there. Okay? So now the question is, we've got all of this. So now we need to find when dx dt is 2. Now, they didn't actually give us an x on this one. No. So we just leave our 4x cubed minus 6x over 2 times square root of x to the 4th plus 3x squared plus 1. Those go away, so the rate of change of this respect to time will be 4x cubed minus 6x over the square root of x to the 4th plus 3x squared plus 1. And if you rationalize that, we just multiplied by this thing, you would end up with 4x cubed minus 6x times the square root of x to the 4th plus 3x squared plus 1 all over x to the 4th plus 3x squared plus 1. And so now, if someone gives you an x, you can plug it into this mess and tell them what the rate of change of distance is at that point, instantaneous rate of change of distance. And this will be, you should get the information you need to do the first part.